Now that we have our STL files, we will open Bamboo Studio. Once open, we can drag these 3 files in at the same time. Press OK to them being loaded as parts for a single object. In the bottom right corner, click Repair to optimize the models for printing. Once that's done loading, we can observe the left side. This contains information about our printer, its hardware, the filament we'll be using, and the print's parameters. First, let's understand nozzles. Nozzles range from 0.2 to 0.8 millimeters. Generally, a smaller diameter nozzle will give greater detail, but a longer print time. We will be using 0.6 millimeter nozzles for its balanced result amongst the filaments that we like. As for filaments, for softshell applications, we will be using TPU 95A HF. This filament is flexible, suitable for softshells, and allows for high flow output, minimizing print time. For a firm yet flexible application, we will use TPU for AMS. This can be very firm with the right thickness, and it can act as a copoly substitute and be printed simultaneously with the 95A. Lastly, for a very firm and strong filament, we use PA12. It's a nylon filament for high-walled UCVL shells. This filament requires high extruding temperatures and is not suitable to print simultaneously with TPU. It also requires an extra step for printer bed maintenance, so a separate lesson will be dedicated to UCBLs once it's implemented within the same software. To assign filaments to parts of the object, click on the Objects tab. You'll be able to highlight the chamfer, name, and print objects. Where there's a color and a number on the right side of the objects, click a few times on it until the drop-down appears. You may now select the filament that you wish to use for that part of the orthoses. I'm going to make my name white. Since I'm going for a copoly substitute, I'm going to make my print object white as well, seeing as number 2, or the white, refers to TPU for AMS. Now we must select the densities. With the intended object selected, navigate to Strength and scroll down until you see Sparse Infill Density. For TPU for AMS, as a copoly substitute, we will always want the infill at 100%. This will make it simpler to grind and rigid enough. For TPU 95A HF, we might decide upon many different densities that can be felt with the sample print squares. Feel what you would like as a clinician and input that density. Also make sure that gyroid is selected. This lattice structure gives the best results for this purpose. If we are printing with multiple filaments, this tower will appear. Just put it to the side. We can now slice the print. Once sliced, use the sliders to make sure that everything looks right, that your lattices are on the right object, and the name comes through. Also, if you're getting this error saying there's a floating cantilever, go to Global, and then Enable Supports, and ensure that the raft layers are at 0. Now it should slice without any errors. You can now send it to the printer. The left nozzle will automatically sync up with TPU AMS as the filament is present within the printer's spool holders. However, TPU 95 needs a special drying unit, so we must tell the printer that TPU 95HF will be coming from an external spool. As long as the printer maintenance has been kept up to date and the spools have sufficient filament, then the print should come out nicely. In the next lesson, we'll be going over printer maintenance procedures to ensure success and mitigate misprints.